Hey everyone, welcome back. My name is Jordan Parham and we're going to be continuing with our AZ-104 Azure Administrator Lab walkthrough series. So if you haven't already, check out the prior two videos that I've uploaded because we're going to be building on those concepts, because today we're going through the lab on traffic management. So our prior two were on virtual networking and connectivity. Overall, these lab exercise walkthroughs are really meant to help you, resolve any blockers you may encounter when working on the labs, and also get that hands-on knowledge and experience within Azure, which I find most invaluable. So let's go ahead and head into the portal and we'll continue from there. So on the left, I have the GitHub lab exercises, and I've provided that link to you all. And on the right, we have, of course, the Azure portal, which is portal.azure.com. With this particular scenario, we're going to be setting up some virtual machines, and this is going to be within a hub and spoke network topology. That has a couple of benefits. One is just manageability along with efficiency. But I would say most importantly, the benefit to hub and spoke is security. We're also going to be creating some user-defined routes because we're going to force traffic to the hub. So we have it's going to be broken down in a couple different tasks. The architecture does look fairly complex. However, if we break it down task by task, it will just be, we'll get the hang of it. So let's go ahead and start by provisioning our environment. Here we're really referencing the course files for this lab, and you can find that by going at the top here. And these required lab files can be downloaded. I already have it downloaded, so I am going to upload this to my Cloud Shell. So if I select at the top right this terminal icon, and I'm going to choose this upload and download files icon. I'm going to upload both the parameter and the template JSON files. Oh, I do want to call out, you can only upload one file at a time. So I've just uploaded my template JSON. I will go back and upload the parameters JSON. Okay. I know that this was successful because I can select this open editor and scroll all the way to the bottom, and I can see my two JSON files that I've just uploaded. Okay, next it's instructing us to open this parameters JSON, and let me expand so that you all can see. And we want to change this default password that is set for our virtual machine. Ideally, you'd use an Azure Key Vault to store something like a password. In this case, we are going to update our password within this editor within the Azure Cloud Shell. I've updated the password for within my parameters JSON file. You want to make sure that you do save those changes, so you could do a control save, or at the top right there is an ellipsis and you can select save. From there, I am going to create a variable called location. And I'm going to set that equal to an Azure region. My Azure region that I'm going to use is East US. From here, we need to set a variable for our resource group name. In this case, it's instructing us to provide the name of AZ-104-06-RG1. Next, we are going to create that resource group based off of the variables that we've created so far. So I'll say new AZ resource group. Use the name along with the location. Great, so that was successful. Now we want to go ahead and deploy those virtual machines based off of the JSON templates that we have uploaded previously. So we're going to say new AZ resource group deployment. And we're using this backtick so that we can go to a new line without, without this PowerShell interpreting it as an enter. I'll say resource group name and use the variable that I created previously. I'm also going to use the template file that I uploaded. So that's within our home, and specify the name of that template file. And we want to specify that parameter file as well. I got a error. Let me just update. Okay, that was just due to a typo. So all good. This will take just a couple minutes for this to provide us that successful message. Great, so this was successful. We can see that we have this provisioning state succeeded. So we can go ahead and move to our next step, and we are going to install this Network Watcher extension on each of the virtual machines that we've just deployed. Okay, so because we've already created a variable called resource group name, it has the same resource group name. I'm not going to run this first line along with the location, because what this is walking you through is getting the location of the resource group, but we've specified that in the previous step, which is East US. What I am going to do is create let me clear this so that it's at the top of the screen now. I am going to create a variable called VM names and set that equal to get AZ VM, specify the resource group name, okay, so that was successful. I am going to just show what these VM names are. So these VMs 0, 1, 2, and 3, we created it within our deployment with our very first step. From there, we're going to run this for each. And this is going to run through each of these virtual machine names. We've listed the output of what those VM names consist of, and it's going to install the Network Watcher extension on them. So we'll say VM name in VM names, set AZ VM extension. Again, we're using this backtick so we can go to a new line without PowerShell thinking we are selecting enter. We're going to specify our resource group name, of course our location, our virtual machine name, the name of the extension that we're looking to install, which is Network Watcher Agent. The publisher, which is the format of Microsoft.Azure.Network Watcher. Our type, which is Network Watcher Agent Windows. And of course, lastly, we have our type handler version. Wonderful. And of course, we need to close our curly brace. And this will take some time. So I'll come back to you once this has been successful. Alrighty, so that took a couple minutes. This was successful, and we see the, success message for all 4 of our virtual machines. For our next step, we can go ahead and close the Azure Cloud Shell, and we're going to navigate to our virtual networks. From there, I'm going to select VNet 2 and go into the properties. From there, I want to take note of this resource ID. So I'm going to copy that to my clipboard. And I'm going to put this within a notepad so I can reference it later. Okay. I am going to do the same thing for Virtual Network 3 as well. Go under Properties and get this resource ID. Great. We're doing this, we're making a reference of this resource ID to help address, the portal not showing the new virtual networks that we've deployed when we create our peering. So this is kind of a just in case. So from here, I'm going to navigate to VNet 1 and go ahead and add that peering. So I'll select peerings and add. And this is where I want to specify AZ-104-06-VNet1, which is what we've navigated to, the peering to VNet 2. We're going to keep our traffic to remote virtual network as allow, which is the default. We are going to change this as far as traffic forwarded from remote virtual network to block. So we're blocking traffic that originates from outside the virtual network. We're not using a network gateway or route server, and our peering link name is going to be VNet 2 to VNet 1. We want to keep our virtual network deployment model as the resource manager. Classic is an older way of, or I'll say older and original way of deploying resources within the portal. But most likely you don't want to select Classic, especially not in this case. I am going to scroll down, and this is where we're going to enter that resource ID, because we can see here it's showing that we don't have any virtual networks within this subscription, which is not accurate. So I'm going to go ahead and put in, I know my resource ID, and use the resource ID of VNet2. So let me navigate to my notepad and get this first resource ID. We're going to keep our traffic to remote virtual network set for allow, which is the default, along with the traffic forwarded from remote virtual network. We don't have a virtual network gateway or route server. So I'm going to go ahead and select add, and this will take just a moment. Okay, we can see that was successful. We have created a peering of VNet1 to VNet2. Now we want to create the peering from VNet1 to VNet3. Go ahead and add. I'm going to specify, I'm going to specify my peering link name, which is the AZ-104-06 VNet1 to AZ-104-06 VNet3. I'm going to keep the default to allow traffic to the remote virtual network, but I am going to block traffic, very similar to what we did previously. We're keeping this virtual network gateway or route server set for none. I'm going to specify this peering link name. So instead of VNet1 to VNet3, we're specifying it as VNet3 to VNet1. Wonderful. We'll go ahead and continue on. We're keeping this again as the resource manager for our deployment. And we're going to say, I know my resource ID, and reference that notepad where we stored. Okay, so from here, we're going to keep our traffic to remote virtual network set for allow, and same for all of the remaining. So I'll go ahead and select add. Wonderful, we can see that was successful. This is updating, and once the peering status is successful, it's going to show as connected. So we just created this VNet1 to VNet3 peering. We can see it's updating. Okay, I did a quick refresh and we can see that both of these peers are connected. Now we're going to test this transitivity within our virtual networks. So I'm going to navigate to our network watcher. And from here, I'm going to choose this connection troubleshoot under these network diagnostic tools. I'm going to specify my resource group as the resource group. Okay. Okay, so I've navigated to Network Watcher and my connection troubleshoot tool. And notice here, we don't see the resource group. So I would just advise to be patient. It takes some time for it to update within the portal. I'm going to do a quick refresh to see if that solves it, but if not, we're going to have to take some time. Okay, let's take a quick break, walk your dog, get some tea, some coffee, and we'll come back once this has updated. Okay, I am back. It's about 30 minutes later. I got some tea, listened to one of my favorite podcasts, and I'm going to go ahead and refresh the browser. And let's go into our network watcher for our connection troubleshoot. We can see that our resource group has been updated. So if you ever experience within going into this connection troubleshoot and in general within network watcher and it's not populating the appropriate resource group, it does take some time. So be mindful of that. Continuing on, I'm of course choosing my subscription, my resource group. My source type is going to be set for this virtual machine. We have our VM0. We're also going to specify, we have a couple options. We can specify a select virtual machine and choose from these drop downs, or specify this IP address. Now notice this 10.62.0.4 is matching the IP address of VM1. And I'll show you that within the portal, how we can access and just confirm that that's the case. I'm going to search for virtual machine. So we are confirming in this case with Network Watcher, with their connection troubleshoot, that we're testing the connection between VM0 and VM2. We can see this IP address is matching up, and I'll confirm within the portal as well. So if I select VM2, so the overview blade shows the public IP address, but I know that this isn't a public address because of the format of the IP address, with it starting with that 10. That is a private IP address. So I'll go ahead and select networking, and I can see that NIC private IP. Great. I just wanted to confirm that before continuing on. So I can choose to specify manually, and I want that 10.62.0.4 address. We're going to keep our protocol for TCP, and our destination port, we want 3389. I'll go ahead and check. And we want these results. I'm going to scroll down. It's at the bottom here. We want these results to return the status of reachable. Okay, so our status did give us that reachable confirmation. Okay, now I'm going to check the connection between VM0, which is within this first VNet, and VM3, which is within our third VNet 3. Okay, so we're going to follow the very similar steps. We're specifying our VM0, and we can choose to select a virtual machine and use the drop down, or specify the IP address manually. We'll keep all of these settings the same, and I will do another check. Okay, so this returned the status of reachable, which was expected, and if I reference back to the architecture diagram, we can see because in our previous step we went ahead and created that peering. Okay, let us continue on. We are checking the status between our virtual machine 2 within this virtual network and our virtual machine 3, which is within VNet 3. So let's do that. So for this step, I'm going to be testing the connectivity between our virtual machine 2 and our virtual machine 3. So again, I'm going to choose to specify the IP address manually as the exercise outlines us to do. I'm choosing our IP address here along with our TCP protocol and our destination port. I will go ahead and select check. This is going to take a couple moments. Okay, so we can see that our status is set for, or returns as, unreachable, which is a good thing because based off of our architecture diagram, we did not peer these networks that our virtual machines reside in. So VM2 cannot connect to VM3. Okay, let's go ahead and continue with task 4 to enable these user-defined routes within our Spoke virtual network. So I am going to navigate to VM0 within the portal. And from here, I'm going to select networking. And under this network interface, I'm going to click into this NIC 0. And under settings, I'm going to select IP configurations. I want to change the IP forwarding to be enabled, and I need to save these changes. Okay, from here I'm going to go back to this virtual machine 0, and I'm going to use the breadcrumbs at the very top. That just makes it easy to navigate within the portal. From here I'm going to select the run command under operations, and I want to select run PowerShell script. The reason we're running this PowerShell script is because it's going to help us with enabling routing within the operating system of our virtual machine. In this case, it is VM0. So let's go ahead and copy these remote access window server role so that we can install it. I will go ahead and select run, and we want to get confirmation that this was successful. Okay, we can see that the output did give us that success confirmation. It did take a moment for us to get the output, so be mindful of that as well. From there, I'm going to run this following PowerShell, and within this install Windows feature, we can see we are specifying to include the management tools, and this RSAT is, or RSAT stands for Remote Server Administration Tools. So with these steps, we're really getting the necessary tools for us to enable routing within our virtual machines. So I'm going to go ahead and copy this over and run. And again, this is going to take some time. We can see that the execution is in progress. Great. We can see that this execution has completed, and we got that confirmation that it was successful within our output. Now let's go ahead and create our user-defined routes. We're going to navigate within the portal and search for route tables. From here, I'll go ahead and create. Of course, we're specifying our subscription, our resource group. We need to specify our region, and this region needs to be where we created our virtual networks. So at the very start, when you deployed your environment, use that region. And if you're not sure which region you used, I can go back to the portal, go to my virtual networks, let's say VNet 1, and on this overview blade we can see my location is indeed set for East US. So let's go ahead and continue. We're going to specify this route name as AZ-104-06-RT23. And for our propagate gateway routes, I'm going to choose no. I'll go ahead and review and, oh, let me actually select no. We'll go ahead and review and create. And create. Okay, this deployment is going to take some time. Oh, look at there. It's actually fairly quickly. I can go into the resource, and from here I'm going to select routes, and I'm going to add a route. So we can see here we're going to specify this route name as AZ-104-06-route VNet 2 to VNet 3. Great. We're specifying our address prefix, which is an IP address, and we'll go ahead and specify down below, so 10.63.0.0/20. This next hop type is going to be your virtual appliance, and the next hop will be 10.60.0.4. Okay, we'll go ahead and select add. Great. So what did we just do? Let's go to our architecture. Well, we specified our address prefix as 10.63.0.0, and where do we also see that prefix? We see it within our virtual machine 3, and we've specified our next hop as this 10.60.0.4, which is representing VM0. So this virtual machine is going to act as a virtual appliance. Okay, let us go ahead and continue. We're going to navigate to subnets and associate. We're going to associate VNet 2, specifically subnet 0. Go ahead and select OK, and we'll get that success at the very top right. Okay, so with this step where we associated our subnet, what we just did was we associated that route table that we created previously to this virtual network, in particular the subnet within that virtual network. Let's go ahead and continue on. We're going to navigate to route table and create a new route table. Previously we created our route table as 2.3. Now we're going to create a new one known as 3.2. So I'm going to specify my resource group, of course, my region. Again, you want this region to match the virtual network region. We're going to say AZ-104-06-RT32. Man, that sounds like it should be in Star Wars. Okay, we'll go ahead and continue and choose no as our to propagate gateway routes. I'll go ahead and review and create. Create. Once this deployment is successful, I am going to go into this resource And very similar to what we did previously, I'm going to select routes and add a route. So let's scroll down. Our route name is going to be AZ-104-06- VNet 3 to VNet 2. Our address prefix is going to be an IP. Our address prefix source is going to be an IP address. Of course, our address is going to be 10.62.0.0/20. Our next hop type, again, similar to previously, it's going to be a virtual appliance. And our next hop address is going to be 10.60.0.4. And I'll go ahead and add. Okay, we are going to go ahead and continue on. We are going to, very similar to before, select subnets and associate our VNet 3 and the subnet within that virtual network. I'll go ahead and select OK. So we created these route tables in order to change the default routes that were set. Okay. I'm going to go back to Network Watcher and choose the connection troubleshoot. This time I'm going to specify VM2, check the connection between VM2 and this 10.63.0.4 address. And what is that representing? Well, that is representing virtual machine 3. Now recall when we did this connection test previously, it was unreachable. So based off of the route tables that we have created thus far, it should be successful. So let's go ahead and specify our address. Of course, our protocol is going to be for TCP. Our port is going to be 3389. Let's check. Da, 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 da. Okay, we can see that our status is now reachable. Okay, so we can see in the lab exercises, it notes, this is what is anticipated. So great if you get this status. If not, if you get status returning as unreachable, you should restart VM0. Okay. The other thing that it's calling out is another functionality of using Network Watcher. We really just scratched the surface by using this connection troubleshoot, but you can also view under monitoring the topology. So we can filter by our subscription and our resource group, and if we have multiple virtual networks, we can filter by those virtual networks. But for now, this is what we have deployed so far, and we get a graphical overview, a high-level overview of each of those services. My favorite part of Network Watcher is that you can actually select into each of these services. So say I was like, let me go into VM2. I can easily select VM2 rather than having to navigate throughout the portal. So I think it makes it fairly convenient. Okay, let's move on to our next task where we're going to create an Azure Load Balancer. So I'm going to search for Load Balancer, and from here I'm going to create a load balancer. Of course, I'm specifying my resource group, the resource group we created for this lab. My load balancer is going to be called AZ-104-06-LB4. We're going to specify our region. We want this region to be what we have specified for our prior deployments. So in my case, it's going to be East US, and we're going to keep everything as the default. I'll go ahead and select Next for my front-end IP configuration. We want to go ahead and add a front-end IP, provide any name, a name of our choosing. Okay, I'm calling mine front-end IP config. We'll go ahead and create a new public IP address. We'll call it AZ-104-06-PIP for public IP 4. And we're going to keep everything as the default. I will go ahead and add this front-end IP configuration, and that's all we need to do. I'll go ahead and select Review and Create. We can see we have a couple other options as far as our backend pools, our inbound and outbound rules, and of course tagging as well. But this Basics tab was all you needed to configure in order to create your load balancer. So I'll go ahead and create, and I'll wait for this deployment to complete. We can see our deployment has completed. I'm going to go into that resource, and under Settings, I'm going to select Backend Pools. From here, I'll go ahead and select Add. Okay, so the name of our backend pool is going to be AZ-104-06-LB4-BE1. Our virtual network is going to be VNet1. Of course, we're going to keep our configuration and our IP version as IPv4. We'll go ahead and add our virtual machine, which we will be selecting VM0 and VM1. Okay, that's all we need to specify. I will add. And we'll wait for this to complete. Okay, so our backend pools have been successful. Next, we're going to create our health probes, and this is going to help confirm the status of our endpoints. From here, I'm going to add a health probe, give the name AZ-104-06-LB4-HP1. I'm going to keep our protocol for TCP, our port as 80, our interval is going to be set for 5, and our unhealthy threshold is going to be set for 2. We'll go ahead and add. Okay, we're going to go ahead and continue, and I'm going to select this load balancer balancing rules, and I'll go ahead and add. And this is where I want to provide the name AZ-104-06-LB4-LB rule 1. Okay, we're going to keep our IP version for IPv4. For our front-end IP address, we're choosing this IP config that we created previously. Our backend pool is going to be set for this backend pool that we just created. For our protocol, we're going to keep it for TCP and specify the port as 80 and the backend port as 80 as well. Our health probe is going to be the health probe that we previously created. Our session persistence, we're going to keep it on none by default, along with the idle timeout. We're going to keep our TCP reset as disabled, and our floating IP as disabled as well. I'll go ahead and add. So we have created the load balancing rule. From there, I'm going to select front-end IP configuration, and I want to take a note of this IP address. I'm going to paste it into my notepad just so that I have it stored. Okay. Oh, great. So I don't even really need to take note of the IP address, because in the next step, we're going to open a new browser window, and navigate to that IP address that we referenced, and we're confirming. We see hello world. We can see VM1. I just opened in a different window just to confirm, and I do see the hello world from VM0 as well. And that's what you want to confirm on your end. Okay. So going back to verifying, that our browser does in fact show the message of VM0 or hello world from either VM0 or VM1. Why is that? Because we created this load balancer, and it's a load balancing between VM0 and VM1, which is why you need to refresh your browser. It's also recommended that you open in an in-private browser. Okay, so we're going to move into our final task of our lab, and we're going to implement our Azure Application Gateway. This is a type of load balancer to manage our web application traffic. Okay, so this is at layer 7, which is describing our application layer, as compared to before we created an Azure Load Balancer, and this was for our layer 4, so our transport layer. So let's go ahead and see what our application gateway creation is going to look like. So I'm going to search for virtual networks. I'm looking for VNet 1. And under subnets, I'm going to add a subnet, provide the name subnet app gateway. Our subnet address range is going to be 10.60.3.224/27. Great. So we can see we're allocating 27 addresses. 5 of those addresses are reserved by Azure by default. I'll go ahead and keep everything else as the default settings, and I'll choose Save. The reason we specified our application gateway with this subnet of /27 is because it requires that size or larger. Okay, this was successful. I'm going to search for application gateways and choose to create. From here, of course, I'm specifying my subscription, my resource group for this lab. The application gateway name is going to be AZ-104-06-App Gateway 5. Our region, we're going to stay consistent. I'm going to continue and use East US. We're going to keep our tier for standard V2. We're not enabling auto scaling, so I need to choose no. I'm going to keep the instance count set for 2, along with my availability zone. I'm going to keep HTTP2 set for disabled, and our virtual network is going to be VNet 1. Of course, that subnet that we just created. Next, we need to add a public IP. We'll call this AZ-104-06- public IP 5, and I'll select OK. Move on next to our back-end pools. We're going to create the name as AZ-104-06- Gateway 5- backend 1. Okay, we're going to keep the default. Our target type is going to be set for IP address or fully qualified domain name, and our target is going to be 10.62.0.4. Okay, we're specifying two targets. So this 10.62.0.4 and 10.63.0.4. All right, we'll go ahead and add. And why exactly are we doing that? Well, if we reference our architecture diagram, we're creating this application gateway, and we are targeting these two subnets in particular, or I'll say these two virtual machines in particular. How do I know that? Because I'm verifying based off of the IP address. Okay, great. We'll go ahead and continue with our creation of our application gateway. We've specified our backend pool. We'll go ahead and select Next for configuration. And we need to add a routing rule. We want to confirm that we are on this listener tab. Our rule name is going to be AZ-104-06- App Gateway 5- RL for routing rule 1. Our listener name is going to be set for AZ-104-06- App Gateway 5- RL 1 listener 1. Okay. Ooh, those characters together like that. Okay, so our front end IP is going to be set for public. We're going to keep our protocol for HTTP. Our listener type, of course, is going to be basic. And our error page URL is set for no. Go ahead and add. Oh. Okay, so this is good. We need to specify our backend pools. Be mindful that both the listener and the backend pools are required. So I'll go ahead and specify my backend pool. We created that previously. So I didn't have the chance to specifically call it out, but you do need to create a new HTTP setting. So I'll do that here, and I'll give it the name AZ-104-06- App Gateway 5- HTTP 1. Okay, our backend protocol, is going to be set for HTTP. We're keeping the port as 80. Our cookie-based affinity and connection training, both keep it for disabled. And our request timeout, again, is going to be 20 seconds. I'll go ahead and add. Okay, so we have specified both our backend target and our HTTP settings as well. I'll go ahead and select add. We'll continue onward, and I will review and create. It's going to validate and create. Okay, our lab exercise instructs us that it may take up to 8 minutes for our application gateway to fully deploy. So be mindful of that, and I'll come back when this has completed. Okay, we can see that our application gateway was successful. I'm going to go ahead and click in. I'll click into the resource group, and I'll select into the application gateway that I have just created. From here, I want to take a note of this front-end public IP address that's set here. I will go ahead and copy this. And very similar to a previous step, I'm going to open a new browser and use that IP address, and we can see we're getting hello world from VM2. Now we can try to refresh or navigate to another browser window to verify that this does change to VM3. So let me do that. Okay, great. So we confirmed that we are seeing hello world from both VM2 and VM3 based off of that application gateway that we have previously created, targeting both VM2 and VM3. Wonderful. So that really concludes the lab. Next is about cleaning up our resources. Okay, so let's look at this architecture diagram because we walked through a fair amount of steps. First, we really just provisioned our environment. So we used the parameter and the template JSON files within our lab files to create our virtual machines and our virtual networks. From there, we configured our network topology to be within the hub and the spoke. Our hub is represented with VNet 1, and our spokes are represented with VNet 2 and VNet 3. From there, we tested the transitivity. So we tested, can we connect from VNet 1 to VNet 2? Of course, we verified that's the case because we created this peering, very similar with VNet 1 to VNet 3. We also tried, can we connect from VNet 2 to VNet 3? And within task 3, we couldn't at that time. But we configured a router within our hub and spoke topology, specifically within our hub. We tested the transitivity again, and we did see that we could configure. We got that confirmation that we could connect between VM2 and VM3. Within task 5, we created our load balancer, targeting VM0 and VM1, and we tested within the browser. We could switch between each of those VMs. Of course, we just concluded with creating our Azure Application Gateway, very similar as far as the load balancing, but the Application Gateway is at layer 7, which is the application layer. Wonderful. Let's go ahead and clean up our resources. I'm going to navigate to our Azure Cloud Shell, and I want to make sure that I am in PowerShell. And I'm going to say get AZ resource group, specifying the name AZ-104-06, followed by wildcard, so anything. Mind you, we only had one resource group, so this is going to return one resource group. Nice. So that was, we confirmed we had one resource group. We want to go ahead and remove that resource group. So we're going to say get the resource group, we just confirmed that this is the resource group that we're getting ready to delete, and we'll say remove AZ resource group, force as job. So this as job is going to run this in the background. Okay, so that concludes our lab today, all about traffic management. If you made it this far, pat yourself on the back for your commitment to learning, and learning, just expanding your skills. So I'll see you in our next video. Thanks.